So we have been talking about acids and bases, and let's look at what happens when we mix an acid and base together. When we mix an acid and base together, this is what we call a neutralization reaction. And the result of any neutralization is that you get a salt, which is just mixing a positive ion and a negative ion together, and also water. That is also really the key of why whenever we spill acid or base in a lab, that we can't just dilute water or put water onto it, because you'll just dilute it. The pH still stays the same, or it just not the same, but it just won't be affected that much. But when you neutralize it, you actually will completely change the pH, because you will get water as a result. So one really good simulation to look at is the PhET simulation. If you use Google PhET, there's an acid and base pH indicator simulation, and you can play around with like what happens when you add a lot of water into an acid, and you'll notice the pH actually doesn't change that much. So when you spill anything in the lab, especially acid and base, you need to neutralize it to make sure that it is safe to touch. It's not just putting water onto it. So how do we quantify this and calculate the amount? That's where we get this kind of question where you have numbers. So calculate the volume of a 0.200 molar KOH. This is your base because it has your hydroxide, and then this is that is needed to neutralize 25 mLs of 0.115 molar of HCl solution. So you notice that this is an acid and base, and it's going to neutralize. First things first is that I'm going to just write out this neutralization reaction just to see what's going to happen. So I have my hydrochloric acid, potassium hydroxide, and this is going to be a double displacement reaction. That means the positives and the negatives will combine, and you're going to get water, because that's always going to be one product, and then you're going to get KCl. This salt is actually not going to precipitate, but that's okay, because in a neutralization reaction you're not going to get a solid precipitate all the time, but you always will get this water, which is a neutral pH, will neutralizes your solution. So let's put the numbers in here. Is that you're going to have 0.200 molar of KOH, and you're going to have a 0.115 molar with 25 ml. So if we were to visualize this, what you're calculating is that you have a beaker of 25 mLs of this, and you're trying to figure out, you have some sort of volume of this, and this solution has a concentration of 0.2 molar, and you have to figure out what's the volume to put in here to make it completely neutralized. That means that it's going to have a pH of 7. That's really what you're trying to calculate. So the first thing I also noticed that you're given a molarity and a volume. And recall that your molarity equation is moles over volume, or moles per liter. And you can actually now convert and find and calculate what moles are. So let's put these numbers in here. So 0.115 molar is equal to moles, that's what I'm trying to find, over the volume. Since this is in liters, I'm going to convert this right away. So this is going to give me 0.025 liters by dividing by 1,000. And I'm going to plug this in here, 0.025 liters. Cross multiply all this, so my moles is going to be 0.115 molar times 0.025 liters. Let me punch this into my calculator. 0.115 times 0.025, and then I will get this really small number of 2.875 times 10 to the negative 3 moles. So that's the number of moles I have in the hydrochloric solution. So then in a neutralization reaction, remember, your acid and the base cancel each other out. So you have to look at the molarity, or the moles of this. That means that if you have 1 mole of acid, it's going to cancel out 1 mole of your base. If you have 5 moles of acid, it's going to cancel 5 moles of base. And these moles all depend on the molar coefficient. So going back here, we need to look at the balancing reaction, and luckily this is all into 1 to 1 to 1. That means 1 mole of HCl will react with 1 mole of KOH. That's very convenient, because now for our calculation, this one, what we calculated was HCl. That means that if we have this amount of HCl, we also will neutralize this same amount of KOH because they're 1-to-1 molar ratio. So if you have 2.875, you are going to neutralize 2.875 times 10⁻³ moles of KOH. If the molar coefficients were to be different, let me scroll up. Some of these other acids are different, like sulfuric acid, for example. You will have a different coefficient, and then you have to look at the molar ratio for that. But in our case, for this question, this is very convenient. So once you have that, we can actually go back into your molarity equation. We have your moles. Do we have molarity? We do. If you go back to the question, you notice that we have 0.200 molarity. What we have to find is that we don't have the volume. So once you manipulate this equation a little bit, you're going to have liters is equal to moles divided by molarity, and then you're going to plug in the numbers. So 2.875 times 10⁻³ moles. This is all for KOH divided by 0.200 molarity. So let's punch this into the calculator, and you will get 0.0144. I'll round it off there. And this is a pretty small number, but this is in liters. So if I wanted to convert to milliliters, let me just kind of move the next question out of the way. If I want to convert into let me kind of go through this to milliliters, I'm just going to multiply this by 1,000 and move the decimal places 3 times. 1, 2, 3. So it's going to have 14.4 milliliters of KOH. So what did we calculate with this number? What we calculated was that in order to neutralize 25 mLs of this concentration, we need 14.4? Yeah, 14.4 mLs of KOH. So does this make sense? Let's look at the numbers. Well, it does make sense because, first of all, hydrochloric acid has a smaller concentration, so it's not as concentrated. That's why my volume to neutralize it is not the same amount as what I started off with, right? Because this is not very concentrated, so I don't need as much of this KOH concentrated one to neutralize it. That's what you calculated. So that's your first type of neutralization reaction. Watch the next one to look at where the molar coefficients actually change, and you have to use the molar ratio and calculate it that way. So hopefully this video has helped.